So moving along with the same customer with the Albrecht and the Cyanide Meter 1100, we've got his Amstrad, and it has the non-action man mic. It's a made in Japan one, so it's the original £89.99 one, but it isn't the one with the action man mic, and it actually has the power lead, which you rarely find. So, wonder if it's got any fuse in it. So we'll start by looking at that. I've got 15 minutes before I've got to do something else. Yeah, it's 2 amp, that's absolutely fine. I'm not expecting much out of this mic cable, and there's nothing I can do about mic cables. Right, it's got this huge screw in there. Before I open it up, I will tell you what, we'll just test it. Power supply on. So it's lost a knob, and although we've got scrap chassis, we buy just that, we buy scrap chassis. So by the time we come to get them, they don't have any knobs left on them. But I will have a look just in case, because it'd be nice to be able to just give him a knob for that. Mind, he's taken off the right one, hasn't he? Channel 9 switch. Right, let's switch picture in picture on. Let's make sure it's actually on. It is. So, should be doing 4 watts. So I've switched the test set to the 3 watt scale. And all we need to do is plug the test set in. So it's just over, yes, is what you'd call a good 3 watts. So when he measured it, so I think he's reading a bit under on his meter, which is fair enough. He was getting 2 watts out of it, but we're getting 3. Where's my pen? Anyone seen it? It's there. So it's Amstrad. So I'll put 2.9 watts because that's reality. Deviation 1 2 1 1 2 wallow 0.7. Frequency, now the test set's only been on 10 minutes, so we wouldn't be adjusting it. 2779083. Just slightly out of spec, but I say the test set's not warmed up yet. So what we'll do, we'll set the signal generator to 2779083 so that we're testing it off frequency, which it is at the moment, rather than on frequency and giving a disingenuous figure. $79083. There we are, 2779083.085 rather than 125. So turn the RF gain to full, squelch down. Controls need a bit of cleaning. So it's receiving. Doesn't sound very good, to be honest. It sounds like the detector's out. Right, we'll go over to the cyanide meter. And it's doing an incredible sensitivity. It's doing 0.34 microvolts for 12 dB cyanide. So when just turn it down, when his Kerno came in, it was doing 0.56, and by the time we'd done it was 0.37. When his Albrecht came in, it was 1 microvolt. We brought that down to 0.45 in the centre of its two bands, which translates to 0.6 microvolts in the middle of the UK band. So I've always said these aren't as good as... They look swisher than they work. So I don't think we're going to be able to improve on that receiver, though I think the clarity is going to be a bit out because it looks like the detector is slightly out. So could do with the power coming up a bit if that's possible. And if we isn't, we may change the value of the ballast resistor. Assuming somebody hasn't pinched it like happens. Come on, get out. I want to leave the bottom lid on. There we go. So we'll start by doing the VCO. It's important, very important on these sets because they do have a tendency to drift. And I'm also just having a visual inspection to make sure there's no capacitors which are losing their heat shrink because of heat. Let's see if we can find the Amstrad service manual. Right, power it back up. And what do? We go to channel 1. So we're on channel 1. And if I remember rightly, these are, just check that it's not a floating chassis. Can't even find the... I'll just put it onto our crocodile clip. Yes, it's floating. That's fine. It's not floating. That's absolutely fine. So put that on a handy earth point, and if I recall, it's the far side of that capacitor. So it's in capacitor 9. Capacitor 9 is actually that one, yep. And it's the far side of it. Meter in shot, there we go. So it's far side as I thought it was. So we need to adjust transformer 1 to give 2 volts. So it's a little bit high. So T1 is here. For 2 volts. And then in transmit, still on channel 1, we need to make sure it's also 2 volts. So go into transmit, 0.97 minus. That's very wrong. So it's the trimmer capacitor. I'm just going to wiggle that around in case it's dirty, because it does happen. And then we'll start from scratch. .03. So I'm going to let go of transmit, back to receive, 2.02, into transmit, 2.4 this time, back to receive, into transmit, 2.4. We'll just bring that, see if we can bring that down just a fraction. So into receive, 2.02, into transmit, 2.24. Right, it doesn't tell you to do this. I'm just going to go on to channel 40 and just see where we are. So on receive, we've got 3.6. On transmit, we've got 2.9. Back to channel 1. So it's dropping off on transmit as we go up the channels. Channel 20, we've got no transmit. Yes, we definitely need to be lower. Right, so we'll go into the tune-up. So we want, I'll go on the 3 watt scale. No, I won't go on the 3 watt scale, we'll go on the 30 watt scale. I'll tell you what, I'll try and pull it up on frequency. It is out of spec just, I need it to be better than that, but I'm sure it'll come a bit. I'll tell you what, it's there, isn't it? And we'll have to check because this test that's only been on, what, 20 minutes now. Let's just show you. 2779125 toggling 6, it's done it. Yep. Right, so we'll just see whether we can get any more power out of it, otherwise we'll start adjusting the ballast resistor. So that is peak. That is peak. That is peak. And that wants some soldering iron on it. That was peak. And that was peak. So that's it. We're going to adjust the value of the ballast resistor. I'll take that down to 1.8 ohms from 3.3, and I'm not going to take it any lower than that though. Or you've seen what the result is on my videos before, because we come up against these people. Some people have had the bright spark of an idea to take it out altogether and think it's going to do some wonderful power. And it does do some wonderful power, but not on 27 megs. we had one doing more power on aircraft band than it did on 27 megs. Anyway, we're going to leave it at that point. Made a good start with it, and I'll go and take a lunch break. Okay, so I've done that. Changed that resistor, and I'm not going any lower than that. Let's see what we've got now. 3.5. So we'll just tune it at that. Remember, these are real watts on a commercial test set. They're not out of a Zitagi hobby meter that is calibrated. I'll show you the difference. I'll get one out. About 3.6. So I'll just get the Zitagi meter. Four and a half. Right, we'll do the deviation. One, two, wallow. Can I just give it a little fraction more? Wallow, 1, 2, that's better. So let's look at where the meter is on it. So when we key it up, it's right at the top. I'll take that lid off for now. So the preset for that is there. So we want that to read 4. Like that. So the plus 30 light isn't on. So we do need to come back to the VCO. I'm going to probably change some capacitors in there, see what it's not liking. Receive. Now, it was already absolutely superb. So we're now on frequency. I'll just check we still are. A bit high now. Right, let's do the signal generator. Right, so I didn't think the detector was quite where it should be. I may be wrong. Turn the bench light off, switch the oscilloscope on, and I'm sure it's this one down here. So I want an S9 signal on the signal generator. That's a 100 microvolt equivalent. Yes, I haven't forgotten we need to spray those controls if they will take some. Mind you, it's 40 years old. No, I'm on the wrong one. It's that one. Yep, that's improved it. You know what? I didn't have that on. So there we are. That's the signal. I'll just show you once again. We've got the peak. There we go. So that, turn that off, switch that off. Go over to the Cyanide Meter. Turn the volume down a bit. I'm fed up with that. I'm just going to turn the power off. And right, switch it back on. That's better. Oh yeah, we use the Resistor Super 10, just for those of you who need to know. So, as ever, we need the Cyanide Meter to read about 4 dB, so we've got some meaningful movement. If you have a big signal, you're not going to be able to see any adjustment because the radio will be saturated. Front end starts there. No improvement. No improvement. Possibly a tiny improvement. Do these with a bigger signal. That's frequency. The one I adjusted down here inadvertently. Go back to a small signal. See whether we've made it worse. See what it is now. It was 0.34, it's now 0.31. So, you know, I'm surprised I even was able to get anything extra out of that. Won't make any difference whatsoever. So on the S meter, we'll put an S9 equivalent signal of 100 microvolts, and we want it to light S9, which it's just doing. So we want it to just light it a bit better than that. That's Squelch, wrong one. So if we turn the signal generator up, we get all the lights, and if we turn it down, it works properly. That was nearly spot on. So that leaves us with the Squelch, which on this version actually works okay. It's the Hong Kong version and then the fake Hong Kong version that are somewhat of a letdown. So, Squelch. I'm going to turn the Squelch knob to full on the radio, and let's see when the Squelch actually comes in. I'll put the attenuator on the inset picture. So 1, 3, 10 microvolts, 30 microvolts, 100 microvolts. It's exactly where I want it to be. So I may have just inadvertently adjusted the Squelch preset, but in actual fact it's spot on. So the other test on Squelch: turn the signal generator to standby, turn the Squelch to threshold, switch the signal generator back on, see when it comes in. Comes in straight away. So the Squelch will open at 0.58 of a microvolt, and it will stay in till 0.21 of a microvolt. So I'm going to turn the squelch down. Let's see where we can hear the radio down to. Do it at 0.15, 0.1, 0.06, and then I'm off the scale. So I'm receiving off the scale on this. So it's done, except this VCO will not lock on transmit on all channels. So we'll have to look at whether it's got some kind of power anomaly in that section of the circuit. So I'll just have a quick look at the circuit. What's feeding the VCO power supply wise? We've got capacitor 21. It's a bit like me, Tango 21. Anything like that. Capacitor 32. So I think we'll go for 21 and 32. That's all I can see which would be possible effect in that part of the circuit. Usually capacitors are fine on these. I mean, nearly every part of these is Sanyo, isn't it? 32 and 22. Where are they? No, 21. Can't remember what I've told you. 21 and 32. So capacitor 21 is their xenodiode capacitor. Xenodiode capacitor. The capacitor that's not there. How bizarre is that? The missing capacitor. What I'll do, I'll put, it's never been fitted, and it's not even mentioned as to what the value is, so I think it's an option when it's necessary. I'll tell you what, we'll put 10 microfarads in. That's going to be better than nothing, and I can always take it back out if it malfunctions. So, not come up against this before. Mind you, I've only been doing the job 40 years. Okay, let's see what we can get on that VCO lock now. Probably nothing. So once again, oh, we need to be on channel 1. Right, so let's go to channel 40. See if we've got a VCO lock. So we've got we've got 2 volts on receive. We've got, it does differ this. It just he's wandering around. Why would it do that? Yeah, I think we've got a duff capacitor somewhere in the circuit. I really do. It may be locking, but I don't think that's a reliable lock. Not good. Ah, capacitor 100. I didn't spot that before. Capacitor 100, 3.3 microfarads. That would affect it. Capacitor 100 is there. So that's capacitor 100. So we'll switch the power off. Let's get that whipped out. I've got positive to the right from the way that came out. Yes, that's correct. So we'll just test this. Mind you, last time I put this tester on, it said flat battery. It says it's duff. There we go. Right, power back on. Let's reset the VCO again. So on receive 2 volts, on transmit. Tell you what, though, it's still not stable. No, so even though that capacitor was duff, it's not correct. That's not the problem. Capacitor 100. I think we'll look at this behind the scenes and then I'll tell you what the solution was. Well, you know, I've done a weird thing here. I'm not even seeing where it is in the circuit. I've just changed the resistor resistor, capacitor 133. So that one was faulty, if you remember. It made no difference to the fault we got, where the VCO was drifting on transmit. So there's our receive voltage, which is 1.98, and now we've got our transmit voltage of 2.16, and that is pretty steady. So let's go and see whether we've got channel 40. And it's transmitting on channel 40. And it's pretty stable. So I think that's got to the bottom of that. Good. Now, because that's in the receiver, I'm just going to double check the detector, just in case. So put an S9 signal on. And we'll just double check that detector. No effect, that's fine, good. Right, we're done. I'll just listen to how this sounds. Double check the deviation. Wallow, 1, 2, wallow. Testing, 1, 2, 3, 1, 2. What are we on? Testing 1, 2, testing 1, 2, 1, 2, wallow. Haven't we got any audio on this thing? No. 1, 2, 1, 2, 1, 2. Wallow, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2, wallow. I think we've got another situation with a slightly dodgy mic there. Wallow, 1, 2. I'll just open it up and yes. I think we need somebody who'll do online mic repairs, because we don't do mic repairs. It takes a lot of time, and you know, we're only accepting one CB radio a week because we're so got so much on with the organ side of the business that you know, I condense these videos down to 40 minutes or so, but I can probably be 3 hours on a set. Right. 1, 2, wallow, 1, 2, 1, 2. If we did off lead, he's going to be in trouble, isn't he? 1, 2, 1, 2, 1, 2, wallow. 1, 2, 1, 2. Testing 1, 2, testing 1, 2. Testing 1, 2, testing 1, 2. Wallow. Wallow. Just make sure this is tuned. Wallow. Give it a fraction more deviation. One, two, 1, 2, wallow. I'm just wondering if our test mic was kicking around, but I don't think it is. What's this wired for? 1 2 1 2 1 2. Well, it's not wired for this. Okay. One two one two 1 2 wallow. Well, it sounds all right now. So 2 capacitors and the ballast resistor, and we're cooking with gas, which, as they say, not that I've got gas here, it's in the middle of nowhere. So I'll put it back together, and you never know, we may even get a scratchy corner test in. I wanted to get this customer's stuff out of the way. We've done them in consecutive days, which I really can't afford the time to do. Because it brings us on to Midland emergency set, not emergency set, Midland porta pack next. Try and get that started this week. We're on Monday, but we're not supposed to be doing CBs at all in the week. That's a bit loose, that one. Oh no, it's not, it's me. So we've got fantastic receive on this. There's a little whisker there I don't like the look of, and that's my soldering. A potential whisker. I did turn the power off, by the way. I get some strange comments about people thinking that I'm working on things when they're on. Well, yeah, just to reiterate, and I've said, and you've seen it in action before when we had smoke come out of a Moonraker set. I have the power supply set for 350 milliamps when we put a set on, which we don't know whether it works. So initial test, I'll put a set on as the power supply set for 350 milliamps, and if it exceeds 350 milliamps, well, the power supply shuts down. Then when we're going to transmit, the power supply is set for 1.2 amps. Nothing's going to go over 1.2 amps. Some of the new sets draw a lot more current because they've got CPUs and all that, and we will have to set it higher. We've got another preset for 2 amps. So it's got programmable memories in the power supply, and they're set up accordingly. I just reach over, press a button, and it does the appropriate thing. And then, as far as the bench itself goes, it's on an isolation transformer. Now, the power supply we use is a conventional power supply, which has a transformer in it, not a switch mode power supply. I don't like switch mode power supplies. We don't do switch mode power supplies. So it's a conventional transformer, so it's isolated. The whole bench is on an isolation transformer. Then the whole bench is on a contactor with emergency stop switches. And you saw this in action when we had smoke out of that Moonraker, and I hit that emergency stop button within half a second. So, you know, I'm not... Oh, here's a Cybernet mic. Hey! That's what we want. Look, it says Cybernet on it. So where was that hiding when I was just looking for a mic? Power back on. Monitor radio back on. Wallow, 1 2 1 2 1 2. I just wanted to make sure that the deviation isn't over the top with a different mic. Testing 1 2. Wallow. It's all right. It could just hit 2.6, but we'll leave it at that. Good. So we'll put this on the aerial. Again, turn the power off. It's now 7:30 in the evening. Don't think we're going to put all the screws in before pressing the stop button on this video. So let's look at what we've done. I'll tell you what, we better put that that big screw back in there. So it's had 3.3 microfarads at 25 volts, it's had 33 microfarads at 16 volts, it's had 1.8R resistor, which is 6 watt 48525 made in the Czech Republic. Right, we'll put that away. So we've now that came up to 3.6 watts. That is 2.2 to 2.6. It shouldn't be that high, but it's the mic he's got on it. We've got that up, and the sensitivity was superb, and it has come off a tiny fraction. So another pleasing result. It'd be nice if I could find a knob, but as I said, we buy scrap chassis, we don't buy scrap sets. And you know, by the time somebody's sold all the knobs, fronts, cases, meters, anything worth having, sockets, you know, they sell these chassis on and think that whoever's buying what's left is a mug. Well, I'm not a mug. There's some very useful parts left, but not switches and things. Right. Well, Nana Roger. Am I still having the tea or watching telly? And of course, it came in not transmitting on channels above 20 something. Well, Nana Roger. Roger Bleep. Oh, in actual fact, the switch is snapped off, so there's no point looking for a knob. Right, well, thank you for watching the early version of the Amstrad, the genuine Japanese one, and we'll do an on-the-air test in a bit.